No problem. Can you hear me?
Yes.
Okay. I have lots of devices. Great. So this is me. That is not me. That is a student I work with. And I'm the co-director of Math in the City. And I'm going to tell you a tiny bit about that. If you know about Math in the City, will you raise your hand? Yes. Those are my groupies. This is my 5th trip to Sweden, maybe my 6th. So I've been working with many people in the room for a while. Here we are. This is our plan from now until 5 o'clock. You are going to meet a new colleague who is not at your school, number 1. You're going to find out about Math in the City. You are going to hear what I mean by early algebra, and you can decide if you agree or disagree with that idea. We're going to go to a 2nd grade classroom in New York City, and we're going to do an investigation called Mystery of the Foreign Coin, which is good given our cross-cultural arrangement. Well, then we're going to do something called True or Not True. It's a number string. Raise your hand if you know what a number string is. Great. So I have some number string groupies. And you'll get to do some of that work at your table. You're going to meet a frog named MT. And we're going to get MT to do some algebra and do some mathematics with us. After that, we're going to do some algebra of combinations. And I'm going to take middle school or high school mathematics, and I'm going to explore it with you in images. And so you might have a flashback to high school, to secondary school, or you might say, I've never seen this before. But what I want to do today is try to build a trajectory of algebra from very young children all the way through middle school or high school. What after that? Then together, we're going to rearrange the furniture. The cameraman is not happy about this, but it's going to happen. We'll shut off the camera, we'll move some chairs, and in this space, I'll simulate a classroom. You'll be the students, and I'll simulate what I do with students in the United States. And then you should be asking, so what? What do I do tomorrow? What do I do next? And I have some ideas for you, and I think that's it. Yes. So here's what I'd like you to do. You just arrived. You made it. I want you to find someone you don't know in this room. And we're going to have a stand-up conversation with this person. I'd like you to find their name. Great, they have a name tag. Find out where they live and where they work. I want you to find out, why are they here today? Why did they come? What do they want to know? And then I'd like you to find out one thing they are working on in their teaching, one thing they are trying to improve, or they are working together with a colleague or by themselves this year. That is what I'd like you to do. So leave your... It's going to make you move to sit by the new friends, and my colleague said, don't make them move. They've been teaching all day, they're tired, they're sitting by their friends. So normally I would, but maybe you'll have a fika with the person you just talked to. Okay, this is me, and what is important here is that I love doing mathematics with kids and spent many years as a middle school math teacher in New York City. And then I decided that I also love doing math with teachers and with my colleagues and thinking about how to make teaching better. And so now I get to do both. I work in classrooms all over New York City from very small children all the way through high school. And I'm trying to be a K-12 math educator. And it's like a job that doesn't exist. So I'm trying to make a job for myself, which is really fun. And the reason that's important to me is because for me, math is connected and it develops. But when you only see a small slice of it, it feels isolated and unconnected. And so it was designed to be beautifully related, and sometimes we miss that. So what I'm going to try to do today is illustrate how the ideas that we develop in the younger years are connected to what we do later in algebra and maybe even in secondary school. I also do some writing, and I travel around the United States. And I like to come to Sweden. So I was in some of your classrooms today, which is exciting, traveling around. And typically when I come, I do some workshops for teachers. I work at the university, and then I try to get into classrooms as much as possible. So I got to do that earlier this week, and today. And here's evidence that children are thinking in a Math in the City kind of way. So this is a student, we had just finished a lesson and he grabbed the pen and he finished the work on his own. He wanted to show me. And that's at the Gustavi School. And the Gustavi School is here today, yes? Yeah, they are. Say hi. Hi, there they are. We've been working with them for a while. Okay, so Math in the City is a place, but it's also a set of ideas. And it's a place in New York City The woman who founded it is named Kathy Fosno, and she is my mentor and my friend, and now my colleague. And she was interested in the work of the Freudenthal Institute in the Netherlands. And so together, she met a man named Martin Dolk, and they became friends and colleagues. And we took the ideas that the Dutch were doing in the Netherlands, and we married them with what we were trying to do in New York City, which is about mathematizing urban kids' lives and making sure that math was relevant to them. They founded a center in 1995. We've seen hundreds, if not thousands, of teachers in our center, and we work currently with 26 schools in New York City. By the way, there's 1,200 schools, so we are a very, very small portion in New York City, but many teachers in New York City have been to our center. That's us. Okay. Typically what we try to do is build a classroom of mathematicians. So we set up the furniture and we make sure that we're taking ourselves a little bit out of the way so that kids can be at the center of the mathematics. And Math in the City teachers typically do not show their own mathematics or tell mathematics because there's already enough that you can build from kids' ideas. So they try to decenter the teacher to make it about the kids' thinking, the kids' ideas, the kids' questions. This is an example of what it would look like. This takes a lot of work. You have to trust that kids have good ideas, that they're worth exploring, but this is what we're trying to do. And this makes us different. So we don't promise high test scores, we don't promise that everyone in your room is going to become a mathematician. We want you to have the feeling of being a mathematician, and we want you to have the feeling that you know some math and you are contributing to a community. That's that. Today I'm going to talk about a strategy, a big idea, and a model. These are the three things that come out of our center. A strategy is when I walk around the room and I see Clara and I see Anna. I look in their notebooks and I listen and I can see and hear the strategies, particularly if I give you a really interesting problem. If I give you a boring problem, then your strategy and your strategy and your strategy, oh wait, look like my strategy. So I don't give you a strategy to start. I want to know what you do on your own. Today I'll be looking for your strategy, how you solve a problem and how you talk about it. Now, you might use a model. Today we're going to use lots of models, including some new ones that you've probably never seen. And a model is a way to communicate your idea to another mathematician, and we'll talk about how that happens. Today I'm going to be the modeler of your ideas, but you're also going to make a model of a situation. And the big idea is important too. Many children experience math class as different from one year to the next, and even different from one day to the next. It's not a related idea. This is a new problem. I've never seen it before. I don't know how to solve it. If you have big ideas, you start to see how math is connected, and it doesn't feel new all the time. You say, I already know that this is like the one we did last week. This reminds me of Osa's strategy, so I can use that right here. So we have to work not just on strategies and models, but also big ideas. So we took all of that, and we made a messy map, and we call these landscapes. And what we offer teachers is that today we're going to try to build a landscape for algebra in a very short time. This is a map that has strategies, big ideas, and models all in one map. And what we do is we try to locate where children are in the classroom. And our job as teachers is to move them up the landscape, getting them to talk to us, giving them interesting problems to solve, asking them questions. That's how you create experiences to move up the landscape. Okay, I'm going to put this up for a second. Will you talk to the person next to you about this idea? Are these new ideas for you? Are they familiar? What do you think about this related to how you're teaching mathematics currently? Talk just to the person next to you. Go. Water. Maybe what we'll do at the end of our session today, we'll come back and say what were the strategies in algebra, what were some big ideas in algebra, what were some models in algebra, right? So I'll connect it to our work in algebra so you'll have some examples. Okay, we did that. Now I'm going to have you write. You should have an index card. at your table. You even have pens, because we're at a fancy hotel. They give us pens and water and fika. Everyone take a card. We're going to use the front, and later we're going to use the back. Is it okay if I come into this space, or do I make you nervous? I'll probably make the cameraman nervous, because he said he will follow me. Okay. It says post-it note. No, I changed my mind. Let's write on the card. This is not a quiz. So I'm going to collect this and I'm going to read it, but I don't really care what you write. I just want your ideas. Do not take out your phone and Google it. That's not what I want. I want to know for you, what is algebra? So again, I don't want a definition. But if you were described to someone outside of education, outside of mathematics, what is it? And number 2, in Sweden, how do students typically experience algebra? When is the first time that a student says, I was doing something else and now this is algebra? Can you give us an example of what does it look like? So if you say age 6, what does it look like? If you say you're 6, describe how do you know it's algebra if you're a student. Okay, that's what you're going to write. And then at the bottom, if you could sign your first name. I'll give you 2 minutes to write, and then we'll do some math. But the first statement is essentially, I'm thinking of 2 different numbers. One we'll call x, and the other one we'll call y. And when you add my 2 numbers together, you get 53. But if you take that first number and subtract the other number, you get 23. And I just want to know how you would even start to do that problem. If you're writing on your index card, will you find something else? Because we're going to use the back of the index card later. So you can use a handout. There's some white paper on the table. I think there's white paper on the table you can use. There's notebooks. How would you even start this problem? I'm going to let you think for about 30 seconds, and then I'm going to let you talk to someone next to you. How would you even start this problem? Okay, good news. This is not a quiz. You have a way of thinking about it, I think. Will you talk to the person next to you? Put your ideas together. See if you can get a little closer. What do you think? And what is it supposed to mean? So there's a cute image. There she is again. When do we introduce a variable into the curriculum, into our discourse with kids? What do we mean by it? And what do kids think it is? Will you talk to the person next to you about when do you think the variable shows up and make a sketch of what does it look like? Is it an X? Is it a Y? Is it something else?
Nothing, and
And usually it goes here. It's tricky if it goes here.
Vad säger ni om problemet?
Ja, vi förklarar att det redan i årskurs 1 så får man handskas med öppna utsagor till exempel. Fast då är det kanske inte X och Y utan djur. En snigel plus en groda är lika med någonting. Alltså.
Eller 3 plus tom ruta är lika med 8 eller någonting.
Madeline? Yes? And we came up with these ideas at their table. Sometimes they said the variable looks like this. It's some missing number that I'm supposed to find out. But sometimes it looks like a question mark, but it means the same thing. It means find me. And then sometimes they said in the textbook it looks like a blank. And then apparently in some of the textbooks it's ice cream cone plus sunshine equals 8. That is cuckoo. But maybe that's how you do it. I think that's, yeah, you're saying yes? Okay. Are there other ways the variable shows up for young children? Notice this is not an X or not a Y. Are there other ones that we're missing, or are these what you talked about? I'll let you think about that for a second. Yeah. So one question we should think about is when the variable in this quote-unquote variable is going to be 21, right? So the question is, do kids understand that a variable is a quantity that varies? Or do they think the variable is the place where they put their answer? In other words, is there a difference between a missing unknown and a variable that can change? That's what I'm not sure. So we're about to go into a second grade classroom where the teacher is really, really thoughtful about the difference between just a missing unknown. That box, it's really, the value is 21, and it's only 21. Now she could make a new problem with this box, but the kids might think the box is where I put my answer. It's not really a variable. So I want you to think about that difference, the difference between a variable and a single missing unknown. What kids would say is put my answer here, right? Or put the number here to make this true. Following. There's my 25, and inside my 25 is a 10, and a 5. And this model is really clear to kids. So notice there's no 0 here. She's not marking all the 5s. She's making a picture of what kids say, which is I know that 2 10s and a 5 is 25. Because Giovanni is in the room, the kids know that you can rearrange the coins. So as you're working on these problems, remember, you can be Giovanni too. You can do 5, and then you can put the 5 in the middle, or 5 and 2 10s. It's still going to start and land in the same place. So his idea of the rearrange is a big idea in mathematics, and it's going to help them with these problems. With your partner, using this number line, can you find out the value of these 4 situations? Will you make a nice big picture in your notebook so if I walk by I can see them? We're going to take a fika in about 10 minutes, so we're going to go a little bit past 3 so you can do all 4 problems. Okay?
Jaha, du menar du gör den först?
Ja, det var
Jaha, okej, det gjorde inte jag. Jag tog direkt den andra
Ja.
och la 15 där i och så den biten som är kvar där då. Men om vi nu skulle tänka rearrange så kanske detta är det rätta sättet. Inte vet jag.
Man kan göra på 2 sätt.
Det var jättebra Karin. Jag gjorde ett steg snabbare. Du gjorde helt rätt.
I think you might be thinking of that problem differently now that you've seen coin X, perhaps. So now I want you to, I'm just offering these as a few more problems before we have a fika. I'm thinking of 2 numbers, when you add them you get 20, and when you subtract them you get 10. Can you find them? What if you add them and they become 30, but you have a difference, you subtract them and you get 14. Here's my last set if you want a challenge. I'm thinking of 2 numbers. They add to 151, but when you subtract them, you get 49. So, I'd like you to try one of these problems on the number line. Does the number line help you to solve any of these problems?
Så sätter vi 0 här då. Och så gissar vi då på 10 eller?
Ja, för att
Står jag på 0 och så addar jag 30.
Så ska jag dubblera dem, då blir det ju 10 plus 10. Då blir det 20.
X så räknar jag ut skillnaden mellan 151 och 49. Och sen delar jag det på hälften. Jag kan visa. Så... Oj, 151, 49 och sen delar jag det på 2. X.
How much is that? What is it?
51.
So you're saying that X is 51 or Y is 51? Okay, let's do this. Let's take Victor's model.
Oh, Y, yeah.
Y is 51. Okay, if you know Y is 51, and be thinking about if that's true, can you figure out X? Victor's claiming that X is right in the middle of those 2 numbers. And I said, how do you know? Do you remember what you said? How do you know x is right in the middle of 49 and 151?
Because I add or subtract the same value.
Does that make sense? He made a jump of y, he made another jump of y. He's claiming x is right in the middle. Okay, take a minute and see if you can finish his work, and then we'll go to fika. Can you figure out where x is? If y is 51. Okay. I like to send people with some ideas in their heads. So Victor got us started. I think his argument is that all of these problems, you could make a model that looks like this, where one number is a place and the other number is a distance. And somehow one is right in the middle. And we'll think about why is that? Why is one right in